This video demonstrates the work conducted by Skymantics in the machine learning thread of OGC TB15. We will be demonstrating component D102, the New Brunswick Forest ML model. The sponsor of this work is Natural Resources Canada, also known as NRCan. Their goal is to provide science-based knowledge to optimize the economic and environmental value of Canadian forests. The component we are demonstrating is a decision support model for forest supply management for the province of New Brunswick using machine learning techniques. NRCan provided access to more than 30 datasets about the New Brunswick province. It includes forest data, roads, mills, protected areas, and transportation forest roads. It also includes historical datasets on evolving prices for wood and fuel. Here we can see a point of interest for a paper mill. We can also look at the roads and routes within the province. Here you can see a highway route 8. For this model, Skymantics proposed to use a subset of machine learning called reinforcement learning. Widely used in gaming, reinforcement learning focuses on how an agent's actions in an environment can maximize a reward. 3 different types of agents were selected to model the supply chain. 1. A planning agent, 2. Harvest agents, and 3. Transport agents. Their reward was calculated based on the revenue generated by the amount of harvested wood minus the operational costs. The planning agent is in charge of setting priorities based on the status of the mills, the market prices of each type of wood, and the price of fuel. There are several harvesting agents working in parallel in charge of managing operations in the field. They decide whether to harvest from a forest stand, move to another forest block, or build a new road to ease transportation. Transport agents are also working in parallel. These agents are in charge of collecting the harvested wood and bringing it to the best suitable mill. In order to calculate wood transport costs, a routing engine had to be implemented. These processes were orchestrated using an OGC web processing service interface to configure the settings of the agents, launch the training, and execute the full model. Let's look at an example. First, we will set the harvest agent's neural network parameters and train it. Once training is completed, we can see the evolution of the rewards, which is the value of the wood collected minus the cost of operation and the cost of building roads. We can see how the decisions on actions evolved as training progressed. During the training, the algorithm first explores the environment taking actions randomly. During this phase, the reward is basically flat. Once it has explored enough, it starts learning from these experiences and the reward rises. The frequency with which the algorithms choose each type of actions as it learns is worth observing. Harvesting is an action that generates immediate reward, but moving to another forest block or building roads generates costs in the short term, expecting to generate future rewards. The frequency of these 2 actions drop to the level in which they help generate the optimal reward. Once all agents are trained, we can then execute the model. We can define the number of harvest and transport agents that will work in parallel. In addition, we can define the number of years included in each episode and the number of episodes to run. One of the most interesting applications of the results is to analyze the aggregated results of the episodes with the highest rewards. We can visualize them using any tool that can display a GeoJSON format, and analyze what are the most frequently harvested forests or the busiest mills. These results can serve as a blueprint for the multi-year harvesting plan, or to evaluate improvements to operations and optimize the value chain. The model can also be adapted to perform stress tests and identify breaking points in the supply chain that can be strengthened to help overcome future crises. This development by Skymantics is a starting basis for new technologies in forest resource optimization and supply chain planning. It could be applied to other areas such as environmental policy and other types of resources such as water or minerals. In summary, this project in the OGC TB15 was successful in applying reinforcement machine learning techniques to solve a complex business challenge while opening a door to future capabilities.